In this module, we're going to explore the ability of AI assistants to take action. We'll be looking at tools and tool calling techniques. Imagine asking your AI assistant not just for information, but to do something complex, like scheduling a multi-participant meeting across different departments for a specific time, booking the room, and distributing the agenda. This shift from an AI that advises to an AI that executes is an important leap for business automation. As we've seen throughout this course, a typical AI assistant architecture involves instructions, knowledge, and actions, all interacting with a central LLM. In our previous modules, we've covered instructions and how to provide knowledge through RAG. Now, our focus shifts squarely to the actions component, highlighted here in the diagram. We're going to delve into how LLMs can be empowered to go beyond simply processing and generating text to actually executing tasks. This is achieved by utilizing tools which allow the LLM to interact with external systems and data sources. So, let's first establish a baseline. An LLM, when operating in isolation without any external integrations, is essentially actionless. As you can see in the diagram, if a user prompts the LLM with a request like, "I need to meet with the department heads," the LLM can understand this. It can process the request and generate a text suggestion, such as, "I suggest scheduling a meeting." However, it stops there. It cannot, on its own, identify who the department heads are from an HR system, check calendars, or actually send out the meeting invitation. It can suggest the action, but it lacks the ability to confirm details or interact with the necessary external systems to carry it out. This is where tools come into play. When we equip LLMs with tools, we give them the ability to interact with external systems and perform specific business actions, bridging that gap between suggestion and execution. In the diagram, the user still makes the same request, "I need to meet with the department heads." But now the LLM, augmented with tools, can take concrete steps. First, in step 1, it might use a tool to interact with the HR information system or org chart to identify who the current department heads are. Then, in step 2, it can use another tool, a calendar tool, to check their availability and actually schedule the meeting. And finally, in the assistant response, the LLM delivers confirmation to the user, "I've scheduled a meeting on April 24th at 2 p.m. Eastern. Let's look at some common examples of tools that can be integrated with LLMs. For instance, an email tool allows the AI to automate communications, sending notifications, follow-ups, or summaries. Calculators are essential because LLMs aren't inherently designed for precise math. A web search tool enables the AI to retrieve up-to-date market information or news in real time. Data analysis tools can process business metrics from various sources and help generate insights. We've already discussed calendar management for scheduling meetings. CRM update tools are vital for sales and customer service, allowing the AI to access and modify customer data. Document creation tools can automate the generation of reports or standard business documents. And database query tools allow the AI to retrieve real-time specific data directly from your company's databases for accurate reporting or to inform its actions. Each of these tools provides a specialized capability that complements the LLM's language understanding, turning it into a much more versatile business assistant. Now, how are these tools traditionally integrated? For a while, this has been the domain of specialized AI engineers. As the diagram illustrates, connecting an LLM to external systems like an HR system or a calendar system involves several chunks of programming code. AI engineers program tool code functions within the chatbot application itself. For example, schedule meeting bracket in the diagram. These functions define how the LLM can interact with specific external systems. Engineers also write API endpoint calling code to manage that communication. In case you haven't heard of them, application programming interfaces, or APIs, are the standard way different software systems talk to each other. Another communication coding approach involves something called the Model Context Protocol, or MCP. MCP is an open source coding protocol developed recently by Anthropic. AI engineers code an MCP client that calls MCP servers, which in turn front those external systems. The important takeaway here is that all of these methods involve complex programming and require specialized AI engineering skills. This complexity has been a significant barrier to widespread adoption of action-capable AI in many businesses. This is where Integrail AI Studio comes in. Its goal is to hide and simplify that underlying tool programming complexity. As you see in this diagram, Integrail AI Studio has a Universal API feature. Universal API simplifies the process of connecting the LLM to those external systems like the HR information system or a calendar application. It's built for AI creators, people such as business systems, operations specialists, technical product managers, or other domain experts who understand the business needs but don't have coding expertise. Of course, it can also be used by AI engineers as it significantly speeds up their development process. But my point is, coding knowledge is not required. By providing a more user-friendly visual interface, Integrail AI Studio enables AI creators to connect tools without needing to write any code. This significantly lowers the barrier to entry for building action-capable AI assistants. Going forward, Next-Gen EverWorker introduces the Universal Connector. It further simplifies the complexities of connecting to external systems and making sure they work correctly. For example, features like endpoint monitoring can automatically check if an external systems API is available and functioning and correct any issues automatically. It will also support connections to MCP servers, offering another standardized way to interact with diverse external systems alongside traditional API connections. All right, let's ground these concepts in our ongoing example.com security analyst use case. You'll recall the user prompt, what are the security best practices for remote employees accessing company VPN as per our example.com security policy? In previous modules, we addressed the knowledge or RAG retrieval process. We used an Integrail memory set to store the proprietary security policies and an Integrail vector memory search node to find the relevant policy sections. This relevant retrieved knowledge was then inserted into the system prompt of our security compliance LLM to give it the necessary context. Now we're adding a new layer, an action requirement. The security compliance LLM now needs to not only find and understand the relevant security knowledge, but also email that knowledge to users asking company-specific questions. This moves our AI assistant from being just an information retriever to an active communicator performing a concrete business action. So how do we enable our AI assistant to send an email? In Integrail AI Studio, we start by creating a new emailing, or what I'll call the mail action node. The first step is to get the API curl command from your email provider's documentation. Most email service providers give you a sample curl command that shows how to send an email through their API. This command includes the API endpoint or address, how to authenticate, which is where your mail provider API key comes in, and the structure of the data. In case you're not familiar with API keys, most software providers with APIs require you to register with them and get an API key before you can use their API. This is a security measure that ensures only authorized applications can access their services. In step 2, you go into the Integrail palette and click on Node Designer. The Node Designer is where you create custom action tool nodes. Then in step 3, you paste that copied curl command into the Generate Integration window and click Go. Integrail will then parse this command to automatically set up the basic configuration for your new mail tool. After Integrail processes the curl command, the Universal API interface for this new mail action tool opens up, as shown in step 4 on the left. This interface displays the parameters that Integrail has automatically extracted. Step 5 is crucial. You need to inspect and, if necessary, edit these mailing service API parameters. For an email tool, common parameters will be the sender email address, the to or recipient email address, the email subject line, and the email body. You can see fields for sender and to in the diagram on the right. For initial testing, it's a good practice to input your own email address into both the sender and to fields. This allows you to verify that the basic sending mechanism is working correctly before you try to integrate it more deeply into your AI assistant. Once you've configured the parameters in the Universal API, the next step, step 6, is to test the connection. You'll see a Get button. Clicking this button will trigger Integrail to make an actual API call to your email service provider using the parameters you've just set up. This is a direct test of the tool's ability to communicate with the external email system. It verifies that your API key is correct, the endpoint is reachable, and the basic parameter structure is valid. This allows you to confirm the fundamental connectivity before you finalize the creation of the node. Following the test call, step 7 is an important verification. Check your email inbox, the one you specified as the recipient, to confirm that the test email was actually sent and received. You can see an example of a received test email on the left. This step verifies that the action of the tool truly works in the real world. Once you've confirmed that the email arrived and looks correct, you know the tool configuration is good. Then step 8 is to click Create. This finalizes the process and creates the mail action node, making it a reusable component in your Integrail AI Studio environment. Now that our mail action node is created, it becomes available in the Integrail palette under the My Nodes section, as shown in step 1 on the left. This means the mailing tool is ready to be used in any of your AI assistant designs. Step 2 is to add this newly created mail action node to your current agent design pane. You simply click on it in the palette and it will appear on the pane, ready to be integrated into the workflow of our security compliance AI assistant. You can see it placed on the agent design pane on the right, ready to be connected. Before our mail action node can send the email, we need to ensure the content is well formatted. The raw output from our security compliance LLM, which contains the security policy knowledge, is in plain, unformatted text. For a professional email, we want something more readable. So step 3 involves adding output formatting instructions to the system prompt of our security compliance LLM node. We instruct it to format the retrieved security policy knowledge into pretty human readable HTML. Using HTML will allow us to structure the email with headings, bullet points, and other elements to make it easy for the human recipient to read the company security policy advice. In step 3, we see these instructions added to the system prompt. Now we need to connect the output of our LLM to the input of our mail action node. Step 4 shows this. We wire the parsed JSON output from the security compliance LLM node, which now contains our nicely formatted HTML, to the HTML content input parameter of the mail action node. This tells the mail tool where to get the body of the email from. Step 5 points out how this connection is represented in the mail action node's settings panel. You'll see a variable, in this case bracket, 4.json, bracket, in the HTML content text box field. The 4 is the ID of the security compliance LLM node on the agent design pane. You can see it in the black pop-up over that LLM node. And .json refers to its parsed JSON output, which, thanks to our previous step, contains the HTML for the email body. This dynamic linking ensures the correct content is passed to the mailing tool. With all the components configured and connected, the RAG knowledge retrieval, the LLM processing and HTML formatting, and the mail action tool, step 6 is to run the entire security compliance AI assistant. This will trigger the whole workflow based on a user prompt. As the assistant runs, step 7 shows that Integrail AI Studio displays execution information for each node. You can see in the diagram how it indicates the status of each part of the process. This real-time feedback is very useful for monitoring the flow and for troubleshooting if any part of the sequence doesn't behave as expected. The final step in this process, step 8, is the ultimate verification. Check the recipient's email inbox. You need to confirm that the security compliance LLM, through the mail action node, successfully sent an email containing the relevant security policy knowledge, correctly formatted based on the original user prompt. You can see the resulting email on the slide. This confirms that the entire end-to-end workflow is functioning as designed, from understanding the user's request to retrieving specific knowledge to formatting it appropriately, and finally, to taking the action of emailing it. This is a complete automated business process. Now that we've seen how to build an action, let's consider broader business applications. Tool integration opens up a vast range of possibilities. Looking at a couple of examples on this slide, take workflow automation, for instance. It allows an AI assistant to trigger and coordinate actions across multiple systems, like a human process coordinator might. Data analysis tools enable it to perform accurate real-time calculations and derive actionable insights from business data. Transaction processing is another key area where an AI can initiate and confirm business transactions by interfacing directly with financial or ERP systems. Each of these applications leverages the AI's ability to understand requests and then use tools to interact with the necessary systems to fulfill them. As you think about possible business applications in your own company, it's helpful to think about how these AI-driven actions parallel tasks often performed by human job roles. This isn't about replacing people, but about augmenting their capabilities and automating routine operational tasks. For instance, when an AI assistant handles workflow automation, it's performing tasks similar to a process coordinator or an operations specialist. When it performs data analysis using tools, it's akin to a business intelligence analyst. AI-driven scheduling mirrors the work of an executive assistant or calendar manager. Similarly, transaction processing by an AI parallels the tasks of an accounts payable clerk or order processing specialist. In customer service, an AI using tools to update CRMs acts like a customer service representative handling record updates. And when an AI automates document processing, it's performing tasks often done by an administrative assistant or document specialist. The key here is that the AI can take on the system interaction and coordination aspects of these roles, freeing up human professionals to focus on tasks requiring more complex judgment, creativity, and interpersonal skills. So, let's summarize what we've covered in this module on actions and tools. The most fundamental point is that LLMs by themselves can only suggest actions. It's the integration of tools that empowers them to actually perform those actions. We saw that traditionally, this tool integration is a complex task requiring specialized AI engineering skills to code functions and manage API calls. However, Integral AI Studio, with features such as the Universal API and Node Designer, significantly simplifies this process, making it accessible to business professionals without deep programming expertise, what I have named as AI creators. We walked through the detailed practical steps of creating and using a tool. The process steps are listed on the slide. The result is that tool-enabled LLMs can automate a wide array of business workflows, effectively performing tasks that parallel many human operational roles and freeing up valuable human time.